Alrighty, yeah. Here we are. Here we are, my friends. You know? Exponents, right? More with exponents here. We'll do a little bit more on this page here today. Page 7. Not all of these. We don't need to do all of these. And then we'll start page 8. All right. Directions here. Let's refresh our memories. Rewrite it as a radical with no fractional or negative exponents, right? Okay. All right, so let's take a look at number 19, okay? Number 19, 3 over 2 times x to the negative 1/3 power here, people, all right? Now, listen, when you have, right, the base there of x raised to some power on its side here, right? You know, where is that in regards to the coefficient that's a fraction? Is it in the numerator or the denominator, right? So, you know, think about something like this, like 1/2 x, right? 1/2 times x. Or if I just do regular numbers here, like 1/2, right? 1/2 times 4, right? 1/2 times 4 is 2, right? So that's the same thing as saying 4 over 2, right? The 4 goes in the numerator, okay? So if you got something like half x, right? That's the same thing as x divided by 2. So if it's on the side here, like x to the negative 1/3, you know, and you want to rewrite it like, you know, hey, I need to see it, you know, either in the numerator or the denominator, you know, so when it's on its side here, that's in the numerator, people. So that's the same thing as saying 3x to the negative 1/3 over 2. So if you want to have everything together, people, you know, that's how you would write it to start. You know, just rewriting it. And now, all right, let's go ahead and make that a positive exponent. Move it to the denominator. And that's going to be 3 over 2x to the 1/3 power, right? Changing it. We'll change the sign, right, of the exponent, changing the location, you know. And then we are going to do a power over roots, right, with the x to the 1/3. So this will be 3 over 2 times the cube root of x. And there you go, people. That is your answer. Okay, to number 19. Remember, they wanted radicals, right? No fractional exponents, no negative exponents. All right, let's look at, let's go to 22 now. Like I said, I'm just going to move around here a little bit, do a few of these, and we'll, you know, go to the next page. So 22, same deal, right? This is 1/2 times x squared plus 5 to the negative 1/2 power. Once again, that, you know, x squared plus 5, right, to the negative 1/2 is on the side here. So, you know, if you want to rewrite this, this is 1 times x squared plus 5 to the negative 1/2. I'm just rewriting this over 2. You know, if you want to have... you know, if you want to have everything as a single fraction, right? And don't have the coefficient off to the side, you know, that's what I'm saying. if it doesn't bother you and you understand that, that x squared plus 5 to the negative 1/2, in order to change that to a positive exponent, you got to move it to the denominator. Go ahead and do it, if you don't want to rewrite it. So it's up to you. Let's move that right to the denominator, and that's going to be now 1 over 2 times x squared plus 5 to the 1/2 power, right? And, once again, they want this as a radical, so this will be 1 over 2 times the square root, right? The second, or the square root of x squared plus 5 to the first. So when the root is 2, you don't need to indicate that on, the left side of the radical. All right. Because it's implied that it's a square root. Any other root than 2, it does need to be indicated. Okay. All right, so this is your answer. All right, to 22. Let's jump down here. Those ones are pretty similar. Let's do 27. People, 27. 2x to the negative 4/3 power minus 6x to the power of negative 2. All right, once again, you got negative exponents here. Let's make them positive. All right, let's do that first. Change the location. So x, the x is being raised to the negative 4/3, right? The 2 there, it's not like in parentheses that 2x, the 2 is being raised to the power of 1, not to the negative 4/3. If it was, there'd be parentheses around the 2x. And same thing with this 6x to the power of negative 2. It's just the x that's being raised to the power of negative 2. If, once again, if 6 was being raised to the power of negative 2, then there would be parentheses, right? There'd be parentheses there around the 6x. Okay. So that would be what? 2 over x to the 4/3 minus 6 over x squared, right? Changing the location, right? Once again, changes the sign of the exponent, and now we just need to rewrite x to the 4/3 as a power over root deal. So 2 over the 3rd or cube root of x to the 4th minus, and you don't need to do anything with the 6 over x squared. All right. So no. It's not a fractional exponent, right? All right. Yeah, no fractional or negative exponents, right? So do have a radical here. We cannot write x squared as a radical. I guess technically we could, 2 over 1, but no need to. All right, no need to. When you have a positive integer as your exponent. Okay. All right, so that's good with page 7 here. Let's see what's going on with page 8. We'll look at the top half. The bottom half is review. So let's see what we got here with the top half. Rewrite each expression as a polynomial. In other words, get rid of the big fraction. All right, so this is kind of the reverse of what I was talking about with the x over 2, right? Or 1/2 x, right? Remember that when I was like, 1/2 times x, right? It was x, I said it was x over 2. So here, they do want you to split it up, whereby my point here with, with the x being on the side, was to get everything as a single fraction. Have the coefficient embedded, into the fraction. So yeah, so what they want you to do here basically is to split this up, all right? So this is like, you go back to your polynomial division, your algebra 1 type, if, something like 8x cubed minus 2x over 2x, right? You remember that? The old school, algebra 1 types to divide this, basically means both terms here, right, in the numerator are getting divided by 2x. Right, you split it up there. That's what's going on here. That's what they want you to do in these questions. So we'll do a few of these. Okay. All right. So like I said, each term here, you split it up. Split them up. That's usually what I say here with this. Split them up. All right. Divide. Each term here is getting divided by 2x. Right. So if you want to rewrite it, right, so it's x cubed over 2x minus 3x squared over 2x minus 4x over 2x minus 1 over 2x. And then, then we'll simplify this. All right, so what are we going to do here? So x cubed, right, a 1x cubed over 2x to the first. So we can divide the x3 and the x1. x3 over x1, right, has 2x's left over in the numerator. So that's going to be a 1x cubed over 2 or or 1x squared, pardon me, x squared over 2 minus now x2 over x1. Right? x2 over x1 leaves you with 1x left over in the numerator. And x, and then 3 over 2, right? So I'm going to say minus 3x over 2 now. Minus again, 4x over 2x, right? Those x's cross out. And then 4 divided by 2 is 2, right? So minus 2 over 1 or just 2. Minus again. This is 1 divided by 2x, right? 1 divided by 2x there. There's no x, right? There's no x to divide there, so minus 1 over 2x. You can leave it like that if you want. You want to bring up the x and, tidy it up and make that, 1/2 x to the negative first power. You can do that, but, you don't need to. You can if you want. It's fine. You don't have to do that. What do I mean? If you want to tidy this up, all right, like x squared over 2, make that 1/2 x squared minus 3/2 x minus 2 minus 1/2 x to the negative first. That's what I mean. It's, make it, visually a little more appealing. I mean, you don't have to do that, but you can. You know, if you want to put the x to the negative first next to the 1 up there, you know, you can do that as well too. All right. All right, what else here? I'm going to do another one of these guys. Let me do... How about 32? Let's do that next, 32. All right, so once again, you know, split them up. All right, this is not a long division. It's not a synthetic division, right? Because it's a monomial denominator. It's not an x plus 3, right? So you split them up, you know? And like I said, if you want to rewrite it and then divide, you know, or if you want to look at it now as is and then divide it, that's fine as well, you know, if you think... You know, you want to see it a little nicer before you simplify it and rewrite it like this. You can. You don't have to. All right, so what can we do here? 8x to the 5th over x cubed. We can do an x5 over x3. Right, x5 over x3 will leave you with 2 x's. In the numerator, you have an x2 over an x3. Now be careful here. x2 over x3 leaves you with 1x in the denominator now, right? There's an x left over in the denominator. Right, so just keep that in mind, right? You got more x's in the denominator than you do in the numerator. And then 2 over x cubed, there's really not much you can do there unless you want to bring up the x cubed right next to the 2 and make that an x to the negative 3rd power. So let's see here. Let me rewrite this now. So this will be 8x squared minus the 5's in the numerator over x plus 2 over x cubed. And like I said, you know, if you want to tidy it up here, you don't have to, but you can. You can make that 8x squared. You want to move the x up and make that 5x to the negative 1st. And the same thing with the x cubed. Make that plus 2x to the power of negative 3. If you want to do that, perfectly fine, people. All right, either one, all right. Good to go there for number 32, everyone. And that is it, all right, for today, okay? So let me know if you have any questions.